Welcome everyone. So this is our 60-second live stream geometry. We have 5 other people here with us from all different parts of the world. And today I'm going to be doing 5 problems that were sent to me by one of the participants on this session. So I always like it when I'm sent problems because it makes it easier for me. But these problems all come from a book that was written by a previous participant on this session, who's I3435. So I don't know his actual name, but his or her actual name, but that is their sort of nickname online. And he or she wrote a packet of problems that are really good. So 5 of the problems I'm taking from that, and 1 of the problems I'm taking from the Vietnam Math Olympiad, which happened recently. So as always, if you want to join future sessions, feel free to email me at mgreenb801@gmail.com. It's in the description of the video, and we meet on Sundays at 8 a.m. US Central Time. All right, so with that, I'm going to share my screen. Can you all see it? All right, so here's the first question. So this one looked like the easiest. So we have a triangle with incenter I, orthocenter H, and circumcenter O. So yeah, the rest of them look harder, but this one, I don't know how easy or hard it is really. So there's the circumcircle, and here's the circumcenter O. And then we draw the incenter and the orthocenter. So H is the orthocenter. And then draw the incenter. We want to show the parallel line through O to BC, and the polar of H with respect to the circumcircle of BIC. So we know that the circumcircle of BIC has center. I'm just going to draw it for now, but we know the center of that circle. It's the midpoint of arc BC. So let me draw that. And I'm going to make the diagram nicer. So we want to show that those two, so they meet at 2 different points. We want to show, this doesn't look right. GEO King, are you sure this is this is stated the right way? So maybe I'm missing something. Oh, the polar of H. Oh no, sorry, the polar of H. My bad. So what's the polar of H with respect to that circle? I could draw the 2 tangents, but I'm just going to use the polar tool for now. Yeah, they do meet on AI. Okay, so yeah, no, the problem's right. That's my bad. I got confused for a second. Okay, so we want to show that these 3 concur. So I guess I could draw like the tangents from H to that circle. Let's see. Maybe that's better. So I'll shrink the diagram just a little bit. I want to make, there we go. I see someone wrote something in the chat, so give me just a moment. I'm going to draw the 2 tangents from H to that circle. Close this. Shrink the diagram just a little bit. So we have this. And then I don't like seeing the entire line, so I'm just gonna drop that portion of it. So we have to prove that these concur. In the chat, it says, so yeah, I can delete the polar for now. And yeah, next session, Co-Mol sounds like a good contest. Or I think it's a magazine, right? I don't know if it's, yeah, I can okay. But yeah, I can definitely take problems from it next time. Okay. So basically we have this point right here, point K, and we want to show that EF passes through K. Maybe it's worth drawing AH. So we know the reflection of H over BC is this point. So yeah, I guess this problem is kind of tricky because it involves both the in-center and the circumcenter. So we know the distance from this line to BC. So I guess another way to phrase it is if we draw the polar of H and we let it intersect AI at K, we want to show the distance from that to BC is half of AH. That's another way to do it. So I wonder what the polar of K is. Yeah, this problem's harder than I thought.
K is the line from H perpendicular to AD.
Oh yeah, so that would be, yeah.
Can you name the intersection of AD and the last line you draw?
Yeah. So this point right here.
Maybe we can show that dk times dm equals to di squared.
dk times dm is di squared.
Yeah, maybe.
So yeah, that would make things a little easier because yeah, then we could like erase points E and F basically. I kind of like that approach.
Can you also name the intersection of AD with BC?
Yeah.
And the altitude from A to BC.
All right. I'm gonna have to zoom in. There we go. This is actually not a bad diagram right here. Let me just draw these 2 points. So yeah, all these problems were from his book, but they might have been posted by someone else on Art of Problem Solving. So yeah, I should have looked up who, but I ran out of time. So we want to show dk times dm is di squared. So that would mean that h would lie on the polar of k, so k would lie on the polar of h. Should we do inversion about this circle with center d and radius di? I'm not that good at inversion, but I know a lot of these problems with the circumcircle BIC can be solved that way. So basically, we want to show that K and M would switch under that inversion, right? So I wonder what this line, let's see. So that goes to that circle. Yeah, let me do that again. Looks like it passes through like these points right here. Interesting. Okay. So maybe I should label these points this and this. Oh, but it has to. Yeah, that's obvious. If O prime is the inverse of O, then we need to show that HO prime is perpendicular to AI. All right.
In other words, we need to prove that O prime is on HM.
Yeah. Is that just like similar triangles, or let's see, because we want to show that AH over DO prime is equal to AM over MD, right? Let me draw the midpoint of BC too. So would that solve the problem if we showed HO prime is perpendicular to AD?
Yeah.
Yeah. In fact, what does line GJ invert to? So, whoops. Okay, it inverts to that. Yeah, because dk times dm is do times do prime.
I think I can prove that HO prime is perpendicular to AI.
Okay.
It's very easy. You can call the midpoint of MO prime.
MO prime?
Yeah.
Okay.
It's easy to see that GEO is the midpoint of O prime D, right?
U is the midpoint of O prime D.
Yeah, because DO times DO prime is equal to DU times the diameter.
Okay, so hold on one sec. Okay, because basically we have DO times DO prime is DI squared, and DI squared would be like twice DU times DO. Because, yeah, okay, I think I see it. So yeah, U is the midpoint of DO prime. Okay.
Next, we can see that BN is the midline of triangle MO prime D, right?
VU or VN. Oh yeah, VN is the midline. Yeah.
Yeah, and I think it can finish our problem because A H and B is maybe
Why VN is the midline?
oh, hold up. Sorry, VU is midline of MO prime D.
Okay, yeah, I was gonna say I thought it might be VU, not VN. Okay.
Yeah, and since in UV is perpendicular to HO prime, right?
UV. So I know V is the midpoint.
Yeah, because maybe by butterfly. No, sorry.
Sorry.
Let's wait for a second.
Okay.
Michael, I guess the length chasing you said can be done. I'm trying to do it now. I will tell when it is done.
Okay.
Can you hide some point? I think this is very confused.
Yeah.
By EF.
Yeah. Can we say the polar of A to What is that? Let's see. So it meets AI on BC. Is that, I think, so that would just mean that DN times DA. Yeah, that's true. That's correct. I'm not sure if that helps with this problem, but that's true because basically triangle DBN is similar to triangle DAB. And so from there you have DB squared is DN times DA, which is the same, and DB squared is DI squared. So yeah, that's true. So you have N inverts to point A. Sorry, I'm going to erase this in just a second. But yeah, N is not the midpoint of DM. I think Serdar said it was a length chase, right? We have to show that dk times dm is di squared. And that's the same as showing that HO prime is perpendicular to AB. Yeah. So I wonder.
If you let the intersection.
I'm sorry, go on.
If you let the intersection of a perpendicular bisector of BC and let it intersect the arc BAC at some point.
Yeah.
So I guess it is easy to prove that AHWO dash is a parallelogram.
AHWO prime.
We don't know the perpendiculars actually.
I guess O dash is the orthocenter of WBC.
What's the orthocenter
Yes.
of WBC?
O dash. Because O dash is the reflection of D across BC.
Okay.
So that proves that AH equals WO dash. And because they are parallel, so this is a parallelogram.
Okay. That seems like it could be useful. So we have dm times dA is do dash times dw. But we want the ratio am over mb. So maybe, I don't know, maybe that helps.
No. AH is equals to WO dash cos, like the orthocenters are, I mean, it is 2R cos here, that direct formula of the line joining from.
Okay. So we just have to show.
No, that proves. Like we get the parallelograms, so like they are perpendicular to AI. HO dash is perpendicular to AW then.
Okay, so I think that solves it. So let me, okay, so basically we're redefining stuff. So we start by defining, yeah. So yeah, we don't even really need point M. Like, I think it might be confusing, so I'm just gonna hide point M. We want to show HO dash is perpendicular to AI. So I'm going to start out writing this up. So first I'm going to state the in-center, X-center lemma. Sorry about this. So by the in-center, X-center lemma, the center D of the circle BIC is the midpoint of arc BC. So that's the first step, and then we could try to do an inversion. Let O prime be the inverse of O with respect to the circle BIC. And then we want to show HO dash is perpendicular. I'll say, let W be the midpoint of arc BAC. Okay, so first, it's not hard to show this a parallelogram because
O dash is the orthocenter because it is the reflection of B across U.
Okay, so first I'm going to show that. So basically, du times dw is di squared. So we have du times dw is equal to db squared, which is di squared. Actually, let me move this to the other side. Let me write it like this. So that's du times dw, which is du times 2do. Which is 2du times do. So this basically means that U is the midpoint of do prime. Of do prime. And so, so because of that, O prime is the orthocenter BWC. Okay. So how, and then how does that help?
Here's a direct formula for computing the length AH. It is 2R cosine.
So AH is 2OU, right?
2 into circumradius into cos A.
Okay. So hold on one second. Oh, because AH is twice OU and WO prime is also twice OU. So yeah, that's like the well-known fact. So AH equals 2 OU. And then we have WO prime also equals 2 OU. That's like well known. And so that implies AHO prime W is a parallelogram. And that implies HO prime is perpendicular to AI. Okay. And then once we know that, that means so the polar of O prime is this line, right? So okay, so now we can basically say let M be the intersection, or okay, now it's the Z. So yeah, say let Z be the intersection of AI and OH prime. And now it's like a polar chase, right? So we want to show K and Z are inverses, but so since O and O prime are inverses, then K and Z are inverses. So basically, DO times DO prime is equal to DK times DZ. So I'll write that out. So ZKO prime is cyclic. DI squared is equal to D, so that's DK times DZ. And that means that Z and K are Z and K are inverses with respect to the circle BIC. And so now it's all a polar chase because, sorry, I'm almost done here. So so we have H lies on the polar of K. So it implies K lies on the polar of H. And then once we know that, oh, so I didn't even define K. So let the parallel through O to BC meet the line AB at K. So, and then that solves the problem. So the line parallel through O to BC, and the polar of H with respect to C on AI. All right. So we've finished that up. So I'm going to move on to the next one. Nice solution. Okay, so here's the next one. Let me just see who's on. So we have an acute triangle with orthocenter H, and DEF is the orthic triangle. Yeah, I liked how like we proved in the last one that O prime was the orthocenter. That was kind of a cool way of doing it. Okay, so we have D, E, and F. And we might as well draw the orthocenter. X is the foot of the altitude from A to EF. So we know that EF is like anti-parallel to A with respect to BFEC. So yeah, AEF and ABC are similar, and D corresponds to X. So HE and H, so we draw HFD and HED, and we draw the orthocenters. Okay, so I'm going to use this tool. So HE is equal to HE, and then HF is equal to looks like it's off the screen. Where is HF? Is it like way over? There we go. So let me close this and hide a few things that we don't need. We want to prove that HEHF is perpendicular to DX. So that looks okay. Let's check the chat. So it's well known that HEHF passes through the foot of the altitude from H to EF. Oh, really? I did not know that.
Actually, this configuration is well known, isn't it?
Oh, really?
This was asked in Turkey TST.
1
week ago. 8th problem.
So is the whole thing well known, or just the fact that you just said?
We can interpret as a DF as the normal triangle, and it's a in-center config. A is the DX center.
So H is the in-center of DEF, right? Is what you're saying?
Yeah, A is the X center.
And okay, because it looks like FG equals XE, so it's like, sorry. So it's well known that this HEHF
can be proved by polar thing. There's a lemma in triangle ABC. If H is the orthocenter of BIC, then the polar of H with respect to encircle is the what was the name? I forgot it. The line midpoint of the line connecting the midpoints. What was the name?
Oh, midline. The midline.
Yeah, midline. Midline is the polar of H with respect to I.
Okay.
This finishes.
All right. So I think. Do you want me to write it up, or do you want me to move on to the next one? It's up to you guys.
Apparently, H, E, and B are like if you connect B and HE, can you connect B and HE? I think it passes through the midpoint of FD. And also FHEDB is a parallelogram.
FH.
DDHE.
Oh, FHEBB. So like FHE. Yeah, so these are like both parallel.
FHEDB. This can be easily proven by using a well-known fact about the in-center exit configuration. Like so in triangle DEF we have H is the in-center and B is the EX center. And if you reflect B across the midpoint of DF, then that point must be the orthocenter of FHD.
All right. So that point would be the orthocenter of, sorry.
Yeah, so basically you reflect the X center across the midpoint of a segment, then that point must be the orthocenter of, like in this case, is the orthocenter of FHD.
Okay. So, okay, so I'm just going to kind of summarize this because it seems like a lot of you have seen this all before already. So we have like BFHED is a parallelogram. And then we have CEHFD is also a parallelogram. Oops. So we have like those two parallelograms. And then what was the next thing you said? So
that's it. Only the two parallelograms.
And then H is the in-center of DEF, right?
Yeah, I use that fact to the parallelograms thing.
Okay, you use that fact to prove the parallelograms. And then is A the X center of DEF? That's what I think that's what you said, right?
Yeah, yeah. But
Okay.
I also use that fact to prove like the parallelogram things.
Okay.
Yeah, that's all I got. I haven't proved it. I haven't finished it yet.
Okay. Yeah, so Serdar, let's see. So Serdar sent a link to this. See what it looks like. Okay. So Serdar, interesting. This is like a very general, and then Serdar put even a generalization of this, right?
Yeah, by Tavkol.
Okay. Coal. Yeah, so I think we did, I3435 mentioned this before. So yeah, I'm not surprised this was in his book. But I know we did 2 problems actually using this idea before. Okay. So we have those 2 parallelograms. Yeah, we can go on. Yeah, I was just gonna say. Oops, sorry about that. Oh, did I delete? It doesn't matter. So we have a triangle ABC with in-center I. And then we draw the orthocenter BIC. Oh, that's weird. Okay, so call this I. So D, E, and F. And then we draw, so we want to draw the orthocenter BIC. So that would be like some point up here. So it's off the screen right now, but I will try to bring it back to the screen. There we go. I guess it's easier if there's like a taller triangle. Yeah, let me make this a tall triangle. But I don't want it to be like I saw, there we go. Something like that. P is the foot of the perpendicular from D to EF. So looks a little bit like Sharky Devil maybe. And then we draw the midpoint of EF. So it's probably worth drawing a circumcircle of ABC and then drawing AI. So this is P and this is N. The midpoint of VP is N. Oh, did I, oh, is N prime, sorry. GE is the Gergonne point. Oh, this is just the SWOT line. So yeah, a lot of the book are kind of based on well-known configurations because, yeah, I guess he was trying to teach a lot of those. Let's see. So let's draw the Gergonne point. The E, the F, or so yeah, this is the Gergonne point. So we have that. Okay, this is GE. Actually, let me do this. And let me draw this point. Okay. So that should be the Schwatt line of triangle DEF, because you have the midpoint of the altitude, then you have this median point. So yeah,
the notations of iron lemma, H n prime bisects EF comes from iron lemma.
Okay, so these three are collinear because they're on the Schwatt line. And then for H, N, and N prime, you said it's the Iran lemma?
Yeah, using iron lemma.
Okay, let me think about that. How does the Iran lemma show that H, N, and N prime are collinear?
Well, I don't remember what we will use it. Can you draw the intersection of HB and HC with EF?
HB and HC?
Yeah, with EF.
Oops, sorry.
Also, can you delete segments BE and TF? We don't need Gergonne Point.
Okay. And AB too. Yeah, we don't need that point anymore. Sorry, I'm just trying to. Okay. So you wanted me to label these 2 points, right?
And also draw segments CJ and BK.
Yes. So those are going to pass through I. So yeah, I is the orthocenter of HBC. So HI and D are collinear. Let's see.
And now this is just projecting from N to DH.
Okay. Projecting from N on to what?
DH.
DH? Oh, DH. Okay.
Yeah. D goes to B, and prime goes to H prime. Let's call it H prime. P goes to intersection of EF with DH.
Okay, so.
And these are harmonic. So H equals to H prime.
Okay, so hold on just a sec. Let me, so you're projecting through N onto DH. Is that the strategy?
Yeah.
Okay. Okay, so we want to show, what are the 4 points you're projecting through N prime?
E goes to L.
E goes to L.
P. P
Oh,
goes
P
to
goes to L.
yeah. N prime goes to H prime.
Okay.
D goes to D, and I, and the line parallel to PD goes to I.
Okay. So then you have
These are
HLIB.
harmonic.
Okay.
Harmonic
So
bundles, so H equals to H prime.
okay, so that solves it. When was saying, can I draw the intersection of EF and BC, DE, and AB? Hold on one sec. So first I'm going to type up Serdar's solution. So, so first of all, we have GE is the symmedian point of DEF. Okay. All right. And that's since DA, BE, and CF are symmedians. CF are symmedians. I guess that's by definition, but I'm just going to write it. And then, so that means GEN and N prime are concurrent on the Schwatt line. So we have that. And then, okay. So let N prime meet. So obviously H lies on IB. And okay, so yeah, we don't even really need J and K, do we? Yeah, I don't think we need J and K. So, but it's obvious HI and B are collinear.
J and K are used for harmonic bundle.
Oh, okay. Yeah, good point. So let EF meet BH and CH at J and K. So I'll say let NN prime meet IB at H prime. So projecting through N onto IB. Okay, so obviously we have PD N prime comma the point at infinity. Harmonic conjugation. So I'll say N prime is the midpoint of PD. Close that. And then, so projecting through N onto IB. Then we would have L so PD LD LDH prime infinity or LDH prime I. -1, but we know that LDHI is -1. That means that H equals H prime. So then we have N prime GE N and H are collinear. All right. So yeah, we did have to show EF and CI meet on BH, and that's true. That's where we use the Iran lemma. Okay, so by the Iran lemma, EF and CI EF, CI, and BH concur. I'll say define case, oh, I already defined J and K. So I'll say CI passes through J. BI passes through K. All right, I'm gonna move on to the next one. So yeah, once you know the right theory, this is not a hard problem. Let me check the chat. All right. So here's the next one. Oh, the Feurbach point. You guys like Feurbach points? So in triangle ABC, we have the Feurbach point. I honestly, there's very few problems I've solved with the Feurbach point. So let me draw the 9-point circle. We try to draw things symmetrically. DEF, here's the 9-point circle. And then let's draw the end circle. I forgot the proof of the Feurbach point, just the existence of it. I think I could probably recreate it by some time, but so this is FE. I is the end center. H is the orthocenter of BIC, so another problem like that. And it's off the page. Yeah, the Feurbach point moves around so easily, so it's tricky. So reflect A over the Feurbach point. We want to show that AH IA prime and BC are concurrent. That's kind of interesting. Oh, AHBC and the line parallel to I at FE.
Not parallel, tangent.
Oh, tangent. All right. Okay. So does that's probably used in the solution. I'm sure of it, but I don't know if that solves it right away or if there's still like another step. Let's see.
This can be proved via proving EF, A midline, and D, FE intersect at one point.
Okay. So EF, DFE, and the A midline. Interesting. Well, EF is the A.
So actually, it's the opposite. The proof of the intersection of EF. Actually, the first one proves the second one.
Okay. So EF is the A midline, right? I'm a little confused.
All right, EF is the A midline. I want to say that DEF, let's call that XYZ is the in touch triangle, then YZ, EF, and DFE intersect at one point.
Okay, so these two points of tangency. Sorry. So sorry, it looks like a con is jumping back on. So we want the points of tangency of the end circle. Sorry, I just moved the diagram so that I could draw them more easily. That's J, and then we have this point, KL. So you're saying KL passes through that. Wait.
And JFE, not FE, JFE is through that point.
JFE. Ah, interesting. I had never seen that before. Or maybe I had, I just forgot it. Okay.
Prove that we will prove AH, the tangent at FE and BC are concurrent.
Okay. BA I prime C is cyclic, or BA prime IC. Interesting. All right, hold on. Let me make the diagram look a little better.
Sorry, I have seen the configuration that JFE pass through M before. Since F, the Feurbach point FE is antistandard point of a triangle JEF. It can prove that JM and FE are collinear.
JM and FE are collinear.
Yeah, because FE is the antistandard point of line with respect to a line early line of triangle JEF.
Okay, so
DEF, I mean,
so you want me to draw the Euler line of triangle JEF?
no. I mean that the Feurbach point FE is the antecedent point of early line of triangle JKL. It can help to prove that J and F is collinear.
Okay, so it's the anti-Steiner point of the Euler line of triangle JEF.
JKL.
JKL. So it's the anti-Steiner point of the Euler line of JKL. That's what you're saying, right? Okay. I think let's see, Serdar has it saying something else. AH is the polar of, so EF intersect AKL. Proving the existence of G. Okay. Okay, so first you show that G, so okay, basically we want to show the reflection of A over the Feurbach point. Lies on G. Okay, so yeah, I'm not sure. Okay. All right, so how do we prove that G exists?
Trying to find it now.
Okay.
We will use that. Can you draw the altitude, foot of altitude from A to BC?
Yeah.
Now, AN is parallel to HJ, obviously, and AJ is parallel to HD. Using these two, we will prove, we get that GJ squared equals to GN times GD, which implies that GF is tangent to the circle.
Okay. So, did you say AB is parallel to
AJ? AJ is parallel to HD, and this can be proved by reflecting H with respect to D.
Okay, so AJ is parallel to HD.
Yeah.
Okay. Let me okay. So we want to show AJ is parallel to HD. So you said that can be proved by reflecting H over D. HD is the IA median. And JA is the J median of triangle JKL. Okay, so okay.
It is well known that reflection of H with respect to BC, with respect to D is the X center, AX center.
Okay, so the reflection of H over D is the AX center. See, and so JA is the J symmedian of triangle JKL. Or we can use harmonics. All right, see you later, Sardar. Thanks for hopping on. So, and then DJ, FE is the Ponslet point of ABCI. There's so much stuff in this configuration. Yeah. Okay. Thanks, Sardar. I'll see you again. So BAI prime C is cyclic. BA prime. Oh no, it doesn't look like BA prime IC is cyclic. But Sardar was saying that HD is the, okay. Oh yeah, okay, so HD is the symmedian. How do we know that? It's the IA symmedian. Okay, GA over GH. Okay, I'm just going to copy what Hakan just wrote that Sardar said. And so HD is the IA symmedian. Okay, so HD is the IA symmedian of IA, IB, IC, and JKL and IA, IB, IC are homothetic. So yeah, so if you combine those two, that's how you get that. So GAH. So let G be the intersection of AH and BC. So the reflection of A, okay. So this is true. So, okay, so GJ squared is GN times GB. It's GN over GJ. Why is GJ over GD equal GN over GJ? Well, wait, because it's also, oh, because those two are both perpendicular, yeah. So this means that, so G lies on the radical axis of, okay, all right. Because it has the same power with respect to both of them. So G lies on the radical axis of those circles. So since they're tangent at FE, so GFE is tangent to both circles. Yeah, he doesn't know a lot about the Feurbach Point. Okay, so, well, if we know that GFE is tangent and we know that GJ is tangent, okay, so we need to do something with A prime. So AN is parallel to HJ and AJ, yeah, they're both parallel. So yeah, one of them we got using that and the other one we got using that.
Lemma I said actually finishes, I guess.
Can
you name the reflection of J with respect to I?
Yeah.
And the midpoint of AI.
All right. Oh, whoops. They called that J prime, but you want, midpoint of AI, okay.
Now, using using the property of Feurbach point.
Okay.
Feurbach point is the anti-Steiner point of Euler line of KLJ. By using this, we can prove that Feurbach point, midpoint of AI and J prime are collinear.
Okay. And FE are concurrent. So we want to show FEO and J are concurrent.
Now, we know that J prime FE is parallel to GI and O is the midpoint of AI, which implies that FE is midpoint of AA prime.
Okay. So, sorry. So you said a few things about the anti-Steiner point of the Euler line, right?
Yeah. Feurbach point is the anti-Steiner point of Euler line of JLK.
Okay.
Actually, there are other proofs in the book of I3435.
Okay.
There are many proofs of it.
Interesting. All right. So when do you actually J prime? Do you actually you mean collinear, not concurrent, for these 3 points?
Collinear.
Okay. So
now we define A prime to be the intersection of AFE and GI. Then we know that OJ prime is parallel to GI. And O is the midpoint of AI. So FE is the midpoint of AA prime.
okay. So we use kind of a homothety. So so how do we show, okay, so these are collinear using that anti-Steiner fact, right?
It's the one way, but I guess there are easier ways. I'm not sure.
Okay.
I will write in the chat the link when I come back.
Okay. So I'll write it for now. So FE is the anti-Steiner point of the Euler line of triangle JKL. And so that means that FE, So I'll say let O be the midpoint of AI. So this implies that FE, O, and J prime are collinear. And so I'll say so by reflecting over A, so since FEO is perpendicular to FJ, then that means that AI is perpendicular to FJ. So and I'll say A prime I. And so that means that by symmetry, those three are concurrent. So yeah. All right. All right, I'm going to move on to the next problem, but this is really interesting. I didn't know all the stuff about the anti-Steiner point, so it seems like it's pretty useful. The last two F's should be FE. Okay. Yeah, I don't even, yeah. All right. So here's the problem from Vietnam. So sorry, this is the one problem I'm going to do from Vietnam. So